Hello, good morning. Good morning, Harshal. Good evening, Amitesh. Hello, Dheeraj. Hello, welcome all to the TRIE Bootcamp. We'll be talking a lot about a very rare data structure, I will say, but a very important one. Like when we see problems related to strings and in some cases also bit manipulation, TRIE actually helps a lot. I hope everyone is ready. So, have any of you experienced or seen any problem in a contest or have heard about this data structure known as try? It will be easier for me to start from there if I know that how many of you know about tries. Hello Raj, hello Khushi, hello Anand. Okay, okay, so they I think Abhishek is okay, got it. There are people who are completely new to this data structure. Okay. Okay, okay. So then now I have an idea from where we should start. So we will be starting from the very basic only. I mean that was my plan to start from the basic only. Uh, I just wanted to know that how many of you actually know it. It's fine if you don't know it. It's actually a little advanced data structure, I would say. Uh, yes, a little advanced. Good evening, Vikas. Uh, Not an issue, Arindam. We will be starting from the very basic. Uh, no issue there. Hello, hello, good evening. So let's begin. Uh, I hope that my screen is visible to all. So starting off with try bootcamp. Oops, I think now it's fine. I hope my screen is visible to all. So firstly, what was the need of a data structure known as try, right? So if I say that uh, this is a word bootcamp, uh, this is a word boot, boot camper. I'm not sure if all four of them hold any meaning, but it's fine. Uh, the problem states you have to say You have to give me the biggest prefix of them. Can you think what is the longest common prefix? Can you guys think of an algorithm uh, to calculate this? Longest common subsequence DP. No, Aditya. I think that it will give. It's not right. It will give a wrong answer. Just to clear Aditya's doubt, let's say this is bootcamp. Okay. This is just for clearing his doubt. He said LCS DP. I'm just clearing that doubt. See, you can create bootcamp. I can modify these three words, such that they have bootcamp as a subsequence. I can create have a dollar here, have a dollar here, and here I don't need it. I can write camp, I can write MP. Now your LCS DP will give bootcamp answer as the longest common subsequence, but it is not the longest common prefix. Longest common prefix, it's still boot. It is still boot. Longest common prefix. Can you see that? Longest common prefix is still boot, right? Bootcamp is the longest common subsequence, I agree, but longest common prefix is now only boot. In the previous case, longest common subsequence and longest common prefix, they both were same, but there can be cases where LCS is not equal to LCP, which is longest common prefix, right? Okay, but it's good that you are thinking uh, of an algorithm by your own. That's good. Okay, so one algorithm which comes to my mind is we can put a pointer towards the start of every word, right? And we can check if all of them are equal. If all of them are equal, we can move every pointer ahead and we can continue searching like this, right? Put a pointer towards every starting of every word and then check all of those pointers. If they are equal, move the whole pointer ahead, kind of like a window, right? Create a window of pointer and just keep checking, right? You can see that, right? We can create a window here. We can check if they are all equal. Yes, B, 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 B. We can move the window here now. Then check O, 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 O. And towards the end, we will end at T. We'll see, okay, T is equal. Exactly, Kirtana. String matching algorithm also works. Um we can apply something like Z function. You are absolutely correct. No, Z function string matching. There can be other string matching algorithms which can be applied. Z function, I think it cannot. Z function gives you um, longest prefix, which is also a substring of the array. I think that's what Z function gives you. Not, I'm not sure. I'm not sure. It slips off my mind. I think longest common prefix, which is also a suffix. Right. So I think all of you understood that algorithm, that we can put a pointer like I equal to 0, j equal to 0, k equal to 0, and l equal to 0. We can keep incrementing these pointers as per the as per the requirement, right? And we can clearly see we will stop after this, because after this window doesn't contain the uh, same character, right? Because this is C, this is C, this is C, but this is not. So the only common prefix which comes is boot. I think everyone is able to see that. Okay, but try to think about the time complexity of this. Can anyone think about the time complexity? In order to give you the time complexity, I can give you number of strings you can take as S. Let's say number of strings is equal to n, and length of string equal to S, and S is less than equal to m. This is the, can you give the time complexity now? I think we all will agree that the time complexity will be n into m, right? For every character, we are going to every uh, for every character we are checking every string. We are going towards every string. So O of n for checking one window, and will be, how many windows will be checking? The length of the longest prefix. What can be the length of the longest prefix? The length of the largest string. Why? Because there can be a case where I give you a same string, for example, bootcamp, bootcamp, and bootcamp. Can you imagine a case where all the strings are same? In that case, our algorithm will run for n cross m, right? So that's the time complexity of the algorithm, n into m. Yes, it's fine. Just let me know. Just let me know if you have any doubt. We're just discussing the need of the tries. What is the need of the tries? We have just seen a problem, a very popular problem, like what is the longest common prefix, and we are trying to see if without any extra data structure can we devise an algorithm up and which gives us optimal result. Exactly, Raj. It's n cross m. Is there any doubt that anyone has in this? I will just check the live chat if anyone has any doubt. No. Okay. Uh, what is the need of the common prefix? It's just a problem. Like, please explain at once. Okay, okay, okay. I will explain it once again for the people who are finding it difficult. Okay, so I came up with an argument. What's the need of try, right? What's the need of try? So for understanding try, why do we need such a data structure? We're trying to solve a problem of longest common prefix, and we got, this is the test case we are working on. There is a word bootcamp, there is another word boot dollar camp, there is another word boot car dollar mp, and there is another word bootcamper, right? and I'm asking you what devise an algorithm to find longest common prefix. So one algorithm we devised was we can go to every element, we can put a pointer on every element. Let's say pointer is I, J, K, L. So I will point here, J will point here, K will point here, L will point here. And if all the elements are equal, then we'll move them ahead. If any of them is not equal, then we break, because then our longest common prefix cannot be formed, right? It's fine, Arindam. We have not talked about what is a try. We are just trying to understand why try is needed. First, we have not defined what is a try. Don't worry. We will define what is a try in some time. I'm just trying to give you an understanding why try is needed, right? Okay, okay. In real life, there are many. Actually, there are many use cases of try, right? You use like, um, let's say, very basic stuff. Let's say I'm typing a message on WhatsApp, and it autocorrects autocorrect a message, right? That autocorrection has try as its try. That's the application of try, right? That's used by try. How? There is a machine learning model which kind of predicts what you're trying to write. Let's say I write bootcamp. Let's say I write boot ma'am. It goes into a model, and that model says, okay, the most probable word that this person is trying to write is bootcamp. And what they try to do is they try to search for the anomalies. Where is your spelling going wrong? And then they correct it. And in order to search, that search function, this first function requires tries. That's one application. There are many applications. Uh, for example, your uh, obviously it contains a little upper layer of machine learning. Like whenever you type Google on Google, whenever you type a search, right? So always, let's say I will write messy. So if I write mess, then it will give me some suggestions like messy, uh, like many words which contain mess as a prefix. You have seen it, right? Whenever you search on Google. Exactly. There are many uh, applications. Like you must have known, if I write MO, then there are many suggestions I can get. These are many suggestions I can get on Google search, right? You can search for anyone. So there are uh, many applications of try. And honestly, when you will see some interview problems, companies ask according to their need of the work. So you will see that Google, Meta, their interview experiences, you will find problems that relate to try, because their work includes uh, involves tries, right? So they're trying to find people who know these things, who know these functionalities. Okay, so coming back to the topic, I hope that now people know why we need tries, because this algorithm takes O of n into m, and you can feel it, like, right? It kind of looks like n square, and we need to do better than this. Exactly, Kirtana, for auto suggesting. That's what I meant. So yeah, so we need to do better than that. What can we do that? What? How can we do better? Okay, let's just try to go towards an algorithm which gives us a better time complexity. Let's say I have an array of 26 length. I hope that by now you guys know why I'm using 26 length, because it contains smaller case English letters, right? So one is A, one is B, one is C, one is D. What I will do is I will connect this. This will be connected to another array. This will be connected to another array. This will be connected to another array. Like in some cases, this can happen that uh, can you I'm just this is just for visualization. Don't panic if you're not understanding anything. This is just for visualization. Okay, just try to visualize it. Okay, there are 26 boxes, and there can be a case where only one is connected to another one, and then there can be a case where this one is connected to someone and this one is connected to someone, right? Just try to visualize. We are not talking about tries as of now. I'm just trying to visualize it. I think you all know about trees. This will somehow look like a tree. Okay. Okay, so now let's say this is a node. This is a node. I will store every a letter and a flag. It will store a character, let's say A, and a flag which will be initially false. And I will depict this node by this A and false. And it doesn't contain just a character. It can contain a lot of characters like A, B, C, D, and a false. It will contain characters and a flag. Okay. Till now understood what's my node. My node will be a box. It will contain some chars like this and a flag. Okay, that's how I'm defining my node. Like in a binary tree, we used to define a node as a node will be having nothing but a int and link towards another node, right? Okay. So this node will be having chars and will be having link of those chars. Okay. Okay. So let's try to create a trie for A, B, C, D, E. Okay. So someone was asking what is a trie. Let me just I will just show you. First, I don't want to get into definitions. First, I want to give you an intuition what's a trie, right? So that you can visualize it with me. Okay. So we'll be having an A and this one is false, connected to B, false. This one is connected to C, false. This one is connected to D, again false. And this one is connected to E, again false. So this is my trie as of now. This is how my trie is looking. This is my tree. Okay. So I am asking, I want to insert another node which is A, B, D. Okay. I will go towards A. I see that A is already inserted. I don't need to do anything. I will go towards B. Okay. Then says C, it is linked to C. So C is already there. I will insert another node which is D. Okay. And whenever my word ends, I will also insert a empty array with a true in it. All right. Means A, B, D, a word ends here, and A, B, C, D, E, and a word's end here. Okay. Okay. People are asking what is flag? Shuman, flag is just a bool. Flag just shows that a word. Flag is just a binary answer. What's the question for that answer? Does a word Is there a word ending at this point? This is the meaning of a flag. Is there a word like, okay, people are asking what is flag? Flag gives, is there a word ending at this point? Is there a word? Okay. So a false means there is a word whose prefix is a, but it doesn't end here. Okay. So there is a word with the prefix b, but it doesn't end here. It's not ending here. There is a word with the prefix d. It doesn't end here, but it ends. When we go towards next, we note, okay, there is a word which must have ended here. A word ends here, right? So flag gives you an answer for this. If there is a word, okay, I feel like a lot of you are confused. Okay, so let's go step by step. Just say we are given a word. Okay, let's not take Maulik. Let's just take someone's name. Someone's easy. Okay, let's take Praveen's name. Okay, Praveen is asking for me to explain this. Let's just take Praveen's name. Actually, I wanted to take two names who have some common prefix. Let's take Shubham and Shakti. Okay, let's just take, sorry, Praveen, Shubham and Shakti. Okay, I will create a I will create a prefix tree. Okay, Ritu, I will explain it again once. Everything. I think I explained it a little quickly, so it kind of vanished from your mind. S. Okay, and I will add false. Why false? Because the word doesn't end here. Okay, H false. Okay, I'm writing F for false. Okay, SHU false. Mm, B false. So those who don't know, I'm trying to create Shubham, trying to insert Shubham in this try. Okay, and here is M. And now here the word ends. SHUBHAM. Here the word ends. So I'm writing a true here. The word ends. Okay. Okay. Now I will insert. Now I will insert Shakti in this. Okay. Okay. I will traverse my try. This is actually the root of my try. Okay. This will act as a root now. Okay. I will search for S. S is already there. Okay. H is also there. Okay. A is not there. Now see clearly. I will insert an A here and create a new link which says, okay, K false, T false, and I false. And now this word ends here. So again a pointer which shows that the word ends here. So I have also inserted Shakti, SHAKTI, and the word ends here. Okay, right. So can you see that now I don't really need to, now if I want to search for common prefix, it's quite simple, right? I just need to see if there is a node that contains one or more characters. Because if a node contains one or more characters, this means that the common prefix breaks there, right? We can see clearly this is the common prefix, S and H. It is like pictorially so simple to imagine, right? We can see that this is the common prefix. Exactly. And now see clearly, like, can we imagine how can we search for a common prefix? We can just, this will be, how will we implement this? This can be a 26 length of an array which will contain links. Everyone will be a null, everything will be a null, but at position of S, there will be a address will be of this H. So every other entry of this array will be null and one entry will not be null, right? So we just need to traverse every array, and for how long? Till we find the longest prefix. So it's kind of 26 into m, right? M is the length of the longest prefix, right? Okay. And now what we need to think is how will we implement this functionality that we know, okay, there are some characters, because there can be a case. Let's just, like this case only. We need to insert all the characters, right? If there is a, we also need to take care of that a. If there is a u, okay. So let's just think how we can implement this functionality. One way can be we can use a map, right? Because using a map, it will be easier. We will not be storing unnecessary memory space, because if you use an array, every time we are using 26 bytes of memory, it doesn't make sense, because at every point we don't really need that. If there is no, think about it, if there is no a b c d e f g h here, then why are we using space for that? So we can use a map. That's a valid argument, but it's fine. We can use 26 uh, bytes of space. It's not much, right? We can, O of 26 into m is kind of O of m, right? That's a definition of asymptotic complexities. That's the definition of asymptotic complexity, that there is no need to optimize this. It kind of works like O of m, right? Okay. So what I'm thinking is, what will be my node? What will be my node? Okay, node. Now we'll define node very clearly. What will be my node? It will be an array of links, we will have 26 entries, right? And it will have a flag which will initially be equal to false. Okay. So I think many people are confused here. I think everyone kind of followed me when I was uh, making this tree, right? I think everyone's understood this tree. Now I'm just trying to think how can I implement this functionality? Okay, one way to implement it is I can just simply use an array. This is an array, right? I hope everybody knows this is an array of node star. That is, it will store addresses of other nodes. That's what a pointer is, right? Okay. So I will create a 26 bytes of memory space. Which will by 26 because I'm assuming that there will be only lowercase letters A, B, C, D, E, F, G, H, I, J, K. Okay, and a flag. And I defined already what a flag means. Flag tells you is there a word ending here. Okay, okay. So we can have a node star link, and there will be some functions which we'll be talking about. So let's just try and code this up. Right, we have talked a lot. I think while coding this data structure, you guys will understand what I'm trying to do. Okay, let me just code it from the beginning only. Actually, I have solved it before, but I think let me first implement it. If you have a doubt, then you can speak up. Okay. Because I feel like while implementing, a lot of doubts get cleared. Because I will also be explaining what a program is doing, right? What a function is doing. I will explain all that. Just give me a second. Till then, you can think of how can we implement what can be function, what can be the functions needed in try, right? Okay, one function which I feel like will be very necessary is obviously inserting a word. Inserting a word is super necessary. One function can be because we kind of saw in our introduction that try is used in Google search. And what does Google search does? Google search gives you a lot of searches based on how many those searches have one thing in common. What the prefix matches, right? You must have noticed that. Uh, so let me just first post the attendance. All right. So I think attendance is now in the chat. You guys can mark your attendance. Exactly, Kirtana, it's just a prefix tree. I didn't really care about definitions because we don't really uh, we need to like understand how it works, what are the functionalities, how we can use it, like application based learning. I don't think so theory is like is of any use in this case. Okay, I hope everyone has marked their attendance. And I'm running a bit late. That's why I'm because we need to learn a lot in this data structure, right? So I hope everyone is done. Let's just continue with the implementation part. Okay, so let's simply comment this out. Remove this. Also remove this. Okay. So first, we will obviously create a class that we talked about a node, right? And now just tell me, be quick and tell me what does this node needs? What are the components of this node that this node should have? Be quick, we just discussed it. So the first thing will be node star links and a flag which will be equal to false, right? Okay. So this is our node for now, and we have declared a root. We need a root, and while declaring try, we will declare a new root. Now, how will you insert? How will we insert a word? That's important. Okay, so we'll first make a copy of this root, and now we'll traverse over that word because we need to put that word character by character, right? Okay. So what's the problem? The problem is if that node, see clearly, I will again, if the node already, think about when we were inserting Shakti, if S was already present, we just go towards the link. If H was already present, we go towards the link. But A was not present. So we inserted A and we created another link and we traversed on that new link. So first we need to check if this node contains our character or not, right? So we need to check if should be a function to check. So if node, I will create a function contains key word I, and if does not contain, then there is a problem. If it does contain, there is no problem. If it does not contain, then we need to do something, right? So first we will code this contains key function, and now we're coding it into our node, right? And this will get a character, and we can simply return links ch minus a not equal to null. We can return that. If it's not equal to null, then this conditional statement will be true, right? That it is not equal to null. And if it is not equal to null, then we know that, let's say we are searching for b, then b minus a will be 1. So if there's at index 1 null is not present, this means b is there. But if this contains key gives a false, what we need to do, we need to be having another function which is put node star node, and this will simply do ch. We will just do node put word I new node, right? Okay. And for node is equal to get word I. Because now we need to traverse towards the next node, we also need to code a get function. The get function will simply return a node star character ch and simply return the link or ch minus a. Okay. Okay, so the insertion works, right? And now set end. We should also set our flag to true because the word ends here, right? So there should be a function known as set end. And what this will do is this will simply turn flag equal to true. Okay, so we have coded the insert function. Now let's just see. We need to code the search function. That's simple, right? We need to just search for a root for the word. So I can simply copy this part. I can use it. If not equal to contains key, then we can simply return false. And now we need to return if where we are standing, is this the end? Is the flag true? Can you see now why there is a need for flag? Because now we are searching for a word, and for word to be ending at a point, we need a flag pointer to be true. Are you guys with me? Do you guys understand? Now there is a need of flag pointer because that flag pointer actually told us that a string ends here, and if a string ends here, this means that word is there, right? The whole word is there. And if it does not end, then this means that word is not there. That word is just a prefix, right? I hope you guys get it. So we can simply return is end. IsNt will be a function. And what should isNt give? IsNt should return true if the flag is true and false if the flag is false. So we can simply return flag. IsNt, we can return flag. Okay, search is done. And think about it. Now we need to code for starts with. Do you think starts with will be very similar to the function of search? At the function of search, we're at the end returning if where we are standing is true or false. But do we need to care about that when we're searching for a prefix? We don't, right? We don't really need to care about if we are standing the flag pointer is true or false, right? We simply return true. In this case, we simply return true. Okay, some people are saying zoom, please. Um, I hope this works. Okay, so we can simply return true because we are searching for a prefix, right? Just try and run this code. Okay, there is some error here. This should not be void. This should be bool function. Oh, I need to make this public. Oops, it's prefix here. Just some small mistakes. Okay, so I hope it runs, is running for the test case. Yes, it is accepted. Okay, so can you guys see that we have followed the principle which you're talking about? We created a node which contains 26 addresses and a flag, and it contains some functions. So I can write the need of every function, checking if try if node contains that character. This is the application of this function contains key. Adding a character to node. This is the application of put function, right? And getting the address of next node. Setting flag to false. Checking if a word ends here. No, void function never returns a value. Okay. So I think I have added certain comments, and we just need to code two functionalities in this case, just searching for a word and searching if our word starts with a prefix or not. Okay. No, void function never returns a value. It was by mistake. I needed to define it as a bool function. I think you guys are talking about this mistake which I did. This earlier it was written this. This is wrong. Earlier it was written this. It is wrong. Completely wrong. It should be bool because I'm returning a value and it is a bool. So it should be bool. Yeah. So I think that's it for today. Uh, we did our target today. We needed to implement tries. We need to understand why tries are needed and what's the functionality behind tries. We are kind of using a little linked list based structure. This is what I mean when I say linked list based structure. We are using pointers to connect our prefix tree. If you have any doubt, then you can stay. A bool is just a data type which can be true or false. Um, those of you who have any doubt, they can stay. Otherwise, the session is over. Um Tomorrow we'll be solving some problems related to try. We'll see how what can be some problems which can be thrown towards us. Uh, we'll be just solving problems related to strings, but then we'll see some application in bitwise manipulation as well. Bit manipulation. You don't know anything about this, okay? I would say just follow this session. If you don't know anything, then try to solve some problems of linked list as well before coming to the next class. And then it will be good. You will try to yeah, you can get this code. I will share the notes in the group which would have been made, whatever group will be there. I will share the notes. I'll share the notes with the support team, and they will provide you the note, the code. Yes, I will share the code in the notes as well. Okay. I can even show the code here if you guys want to see the code. You can just see the code. The code starts at this point, class node, and this is where the class node ends. This is where the class node ends, and here is the class try. Here we implemented three functionalities: insert, search, and start with. So you guys now, I think you guys can even see this video and uh, to see the notes, or I will anyways provide it in the notes. So that's fine. But if you don't get the notes, then you can see the code in the video as well. Then search on net what's the linked list. It will be, that's for you because it will be easier for you to understand what's a pointer, how I declared node star links 26. So you will understand that. And if you have any doubt, then you can discuss it in the next class. I'm here only to help you. Yes. So today we discussed about tries. We first started our argument why try was needed at the first place. We saw it kind of, for now we know that it optimizes search function because we came up with an argument there's a faster way to search for prefix, and we came up with a try. We will see, actually searching is the major power of this try data structure, but there are many other ways as well in which try are used. So first we discussed why try is used. It's very important for every data structure. Why is very important. Why there was a need. So first we understood the need, and then we understood the implementation, how try is formed, and then we coded our implementation, right? Okay, I will send it. It's fine. Okay, so the session ends here. Lead code question number. I think this was lead code question number 208. Implement try. This was the problem. Question number 208 that we solved. Next session will be at the same time. Uh, at the same time at 7 p.m. tomorrow. So see you guys tomorrow. Thank you. Thank you, everyone. Yes, you are right. We didn't perform the longest prefix. Probably we'll do it tomorrow. We'll do it tomorrow quickly because I wanted you guys to understand what is try. I didn't really want to rush through the things because then there will be people. Then there will be some people who don't understand what try is. There will be some people who understand what try is. My focus will be towards the major half who don't understand try. Uh, yeah. Okay. So see you guys tomorrow.